Hi everyone, and welcome to our video on algebra. Okay, so I'm going to give you some very easy examples first, and then we'll talk about some things that you might see a lot when it comes to the AP test. Real obvious one here, let's do like 5x plus 3 equals 33. Okay, so some things that we'll do a lot this year is an equation like this. Obviously, you're going to subtract 3 from both sides, and then you get 5x equals 30. And then from here, we want to divide both sides by 5. And obviously, this cancels out. So we end up with x is equal to 30 divided by 5, which is 6. Okay, so hopefully that kind of stuff is pretty easy for you. If it's not easy, you'll get lots of practice this year. Okay. Another thing you'll see a lot are radicals. You might see square roots. You might see squares. So, I mean, when we talk about velocity, and there's one of the equations that we might use where you might end up with like velocity squared or like final velocity squared. And let's say it's, like 900 or something like that. So remember to keep track of your squares because in this situation, you would want to square root both sides. So obviously the square and the square root cancel out. And so you end up with VF, which we call, again, that stands for like final velocity. It doesn't really matter what the variable is. And then the square root of 900 is 30. All right, and then you're done. Or another example, let's say you have something like, the square root of x plus, or x over 5 is equal to 3. So the easiest thing to do here is to square both sides. All right, in that case, we have x over 5 is equal to 9. And then we can multiply both sides by 5. Multiply this side by 5. All right, the 5's cancel out, and we have x is equal to 45. Okay, so watch out for squares and square roots and things like that. Okay, but one thing that we will see a lot in AP Physics is equation manipulation. Sometimes they don't give you numbers. Sometimes they'll just give you an equation and they ask you to rearrange an equation. And then you might have to like explain what that equation means or explain the relationship, or you might have to rearrange it and then say like what's going to happen. Is something going to increase by 2x? Is it going to increase by 4x? Is it going to decrease by, a quarter or something like that? Anyways, so let's go over some examples here. Okay, so let's say we have an equation. We'll start off with ones that are kind of easy, and then we'll kind of get progressively more difficult. So let's say we have mg equals kx, and then let's say the problem tells us to solve for k. Okay, well in that case, if we're basically just trying to rearrange this equation so that we can get k by itself. And if that's what we're trying to do, then we should just divide both sides by x. All right. And then we just end up with k is equal to mg over x. Okay. So that's our first example. Let's do another example here. Let's say we have mg equals ma. And by the way, these are variables that all mean something when we get to physics. If you don't know what they mean now, that's completely fine. You probably haven't taken physics yet. But we'll talk about what these mean, but these are all examples that you might actually see in physics. Okay, so let's say that in this case, let's say that we're trying to solve for a. Okay, well in that case, we can just divide both sides by m. All right, obviously these cancel out. We have a is equal to mg over m. But notice that we can also cancel these out. We have m divided by m. That can go away as well. And then we just end up with a is equal to g. All right, so watch out for situations like that. That's going to be pretty common where you have a variable that can be canceled out and your equation can be simplified. All right, let's do maybe a trickier one here. Let's say we have, well, I don't want to say what they mean, but you'll see this when we talk about forces. Again, the point of this video is not to understand all these different variables, but just to kind of think about equation manipulation. Let's say in this problem, let's say we're also trying to solve for a. Okay. Well, in this case, again, we can divide both sides by m, right? And then we end up with a is equal to mg minus t over m. Okay, and from here we can maybe think about, is there even more simplifications we can do? We can kind of change this around and go mg over m minus t over m. And that kind of helps us cancel out this part of the equation. And so your final answer could be something like a is equal to g minus t over m. Okay. So again, watch out for those situations where you can simplify. All right, let's do another one here. Let's say we have 1/2 mv squared is equal to 1/2 kx squared. Okay, let's say we want to solve for v. All right. Well, one thing I can see is both sides have a half. So I can actually, like right off the bat, I can just cancel out the halves, and that can make my life a little bit easier. And so I'll just write that again without them. So mv squared is equal to kx squared. All right, and then I can divide by m. That kind of helps me get v by itself. And I have v squared is equal to kx squared over m. All right, and then I'm going to just move over here and write this again, because one thing I can do now is I should probably square root that. So if I square root both sides, I'll end up with v is equal to the square root of kx squared over m. And then there's actually one more simplification we can make here. If we have an x squared in our square root there, then we can kick that one out. We can put the x on the outside. We can just do square root of k over m, and then we're done. Okay. I think I'll stop there, but that's a good example of how we had to deal with a square root or square root. There are some situations where we might get kind of complicated here, where you have multiple variables that are being squared. And again, the whole point is to rearrange your equation and to be able to solve for a missing variable without any numbers. So just manipulating equations and moving things around to kind of separate the one thing that you're trying to solve for. In this case, we're trying to solve for v.